So today we will be talking about a membrane application in water treatment. So what is a membrane? What is actually a membrane? So membrane-based separation technologies are environmentally friendly separation process that are designed to provide effective and economic solution to a wide variety of environmental issues related to water and energy use, including climate change and global warming. So the growth of membrane science and technology is mainly due to the impressive development in materials used for membrane fabrication and modification, improvement in membrane module, and the evolution of a related system, plants, and also equipment. So, what is actually a membrane? In general, we can say that membranes are semi-permeable barriers used for selective permeation of the desired species in liquid or gaseous phases by means of appropriate driving forces. The cell membrane, also we call as the plasma membrane, is found in all cells and separates the interior of the cell from the outside environment. And the cell membrane consists of a lipid bilayer that is semi-permeable, and the cell membrane regulates the transport of materials that are entering and exiting the cell. So in general, we can say that membranes are semi-permeable barriers that use for selective permeation of the desired species in liquid or gaseous phases by the means of an appropriate driving forces. Membranes of different forms and characteristic are generally made from a wide variety of chemically and thermally stable polymer. Both single polymers and polymer blend are considered for use as a membrane, and other materials such as ceramics, metals, and glasses are also used, and a mixed matrix membrane or MMMAs are fabricated. Because of its multidisciplinary character, we can apply membrane technology for utilization in a lot of industries, including the water treatment for domestic and also industrial water supply, chemical, pharmaceutical, biotechnological, beverages, food industry, and so on. As you can see in the figure here, among the application of membrane technology, we can use it for desalting seawater, for use to holding back the seawater intrusion. We can use membrane technology to treat the brackish groundwater, also for water softening, removing color, odor, and other organic contaminants, for use in the soil protection, agriculture, pharmaceutical, medicine, air protection, and many more, as you can see in the list and the figure in this slide. In this topic of membrane technology, what basically we need to understand is what is actually a membrane. So like what I have mentioned before, membrane technology is a separation process from particles to molecules, and a wide variety of membranes are available to design a process. And how does a membrane work? What can it do? And how much does it cost? So among the disadvantages of membrane is the high cost of the membranes and a slow filtration speed. And according to the pore size or molecular weight, filtration membranes, we can classify it into different types, such as microfiltration, ultrafiltration, nanofiltration, and a reverse osmosis membrane. A membrane is actually a film that is a semi-permeable membrane. Is a very thin film that allows some types of matter to pass through while leaving the others behind. So the membrane filters act as a barrier to separate contaminant from water, or they remove particles contaminating the water. We have reverse osmosis, ultrafiltration, and nanofiltration. All use membrane in their different filtration process. So we have a few different membrane types for different types of application. Water treatment process use several types of membrane. So we have microfiltration, MF, and we have ultrafiltration, UF. We have a reverse osmosis, RO. We have a nanofiltration, NF, and we can see the properties of different types of membrane in the table here. And we can see that microfiltration membrane have the largest pore size and typically reject all large particles and various microorganisms. Also in this slide, you can see that the membrane process, the transmembrane driving force involved, and the main field of application for different types of membrane. And you can read about this in the handout that will be given to you later. So the upper table here is a continuation from the previous slide. Now take a look at the table below here that shows the characteristic of the different pressure-driven membrane process. So we have a few characteristic tabulated in the table here in terms of pore size, MWCO, the pressure involved, and also the permeability. So we can see that they are different characteristics of a different membrane. Take a look at the MWCO here. MWCO is a molecular weight cutoff. It is very important terms in membrane filtration. It describes the pore size or rejection capability of a membrane. And the unit is mentioned here. The dA is the unit of a molecular weight cutoff. dA is a Dalton, or the unit for MWCO is Dalton, or dA in short. And from the table here, we can see that the microfiltration has the largest MWCO number, whereas for reverse osmosis, it has the lowest MWCO number. So in general, we can classify membrane into polymeric membranes or inorganic membranes. A membrane can be homogeneous or heterogeneous, symmetric or asymmetric in structure, solid or liquid. It can either carry a positive or negative charge, or it can be neutral or bipolar. And if you take a look at the figure on the left side here, it shows the general classification of membrane. And basically, we can say that a membrane is essentially a barrier which separates two phases and restricts transport of various chemicals in a selective manner. So here we have different types of filtration mode. The first one, we have a dead end flow, where all the water passes through the membrane. The particles are trapped within the membrane structure. And then we have a closed flow mode, where the feed water passes parallel to the membrane surface. Product water permeates through the membrane. The concentrated stream will help carry particles out of the system. And then we have a transverse flow here, where the feed water meets the membrane surface at the right angle. The product water permeates to the inside of the tube. Concentrate washes over the outside of the tube and removing a particle buildup. All right, so now we talk about a membrane configuration. We have a few different types of membrane configuration, as we can see in the picture here. So what is basically a membrane configuration? Membrane configuration refers to the geometry of the membrane and its position in space in relation to the flow of the feed fluid of the permeate. We can see we have a few different types of membrane configuration here. We have a depth filter, we have a spiral wound configuration, and also we have a platen frame. So in terms of desirable characteristic of membrane configuration are, in terms of compactness, the ability to pack as much membrane surface as possible into a module of limited volume. And secondly, in terms of low resistance to tangential flow, less friction, less energy expenditure, less pressure drop along the retentate flow channel. And it should be know that region. We should have a uniform velocity distribution and a high degree of turbulence at the retentate site in order to minimize fouling and also to promote the mass transfer. Also, it should be easy to clean and easy to do the maintenance. And the most important is it should be low cost per unit membrane area. And here we have a few more membrane configuration. As we can see in the figure here, we have a plated membrane cartridge. The plated filter or membrane cartridge is a filter cartridge that is a plated structure, a filter medium. And also we have down here we have a tubular or hollow fiber module. Tubular or membrane module, a tube-like structure with a porous wall, and tubular module work through tangential cross flow and generally used to process a difficult feed stream such as those with a high dissolved solid and a high suspended solid. So a molecular sieve works by absorbing liquid molecules smaller than the effective diameter of its pore, while excluding those molecules that are larger than the openings. And then we have a solution diffusion here. That is where the water will move from the area of a high concentration to an area of a low concentration. And then we have a pore flow model here. And in the pore flow model, the permeants are transported by the pressure-driven convective flow through the tiny pore. So what does it mean by a permeant? A permeant describes something such as liquid or gas that has penetrated or has the ability to penetrate something else. Consequently, a membrane process such as gas separation, evaporation, and reverse osmosis are due to diffusion, or more precisely to the solution diffusion mechanism. On the other hand, ultrafiltration and microfiltration by the pore flow mechanism. So the bottom line here is we can say that almost every industry today requires a filter for their filtration need. Whether it is the pharmaceutical or food and beverage industry, the filter is needed by every industry today. And we have a lot of different types of filter available in the market that is known for their distinctive characteristic.